Hi, it's Jo Karen Hudson. This video is on adding and subtracting radical expressions. Let's start with the definition. What does it mean to have like radicals? First of all, they have to have the same index, must have the same index. That means that they need to be square roots or they need to be cube roots. They have to have the same index. The little number right here has to be the same. They must have the same radicand, and that's what's out here under the radical. The only thing that can differ is the coefficients. Only the coefficients can differ. All right, well, let's look at some examples and see some like radicals. 4 square roots of 2 and 3 square roots of 2. These are both square roots. They have the same index. They also have the same radicand. They have the same thing under the radical. And only the coefficients differ. One is a 4 and one is a 3. All right, let's look at the next example. They have the same index because they're both understood to be square roots. They have the same radicand, the exact same thing under the radical. Only the coefficients differ. You see, one of the coefficients is a -7 and the other one is a 3. The like part here is x square roots of 21. That's the like part, x square roots of 21. When they're like terms, they have to have a like part. Only you add the coefficients. On the third example, both of them are cube roots. They have the exact same radicand, the same thing underneath the radical. Only the coefficients differ. You see, one of them is an 8, and the other one is an understood 1. Adding and subtracting radicals. First of all, we want to simplify radicals wherever possible. We want to add the coefficients of the like terms and keep the variables and the radicals the same. So we'll start off with the first example. The square root of 36, if we simplify the square root of 36, that becomes 6. If we simplify the square root of 25, that becomes 5. If we simplify the square root of 49, that becomes 7. So now we have 6 plus 5 is 11, minus 7 is equal to 4. After we simplified them, they were like radicals. Now these don't look like radicals, but when we simplify them, you will see that they will be like radicals. Let's think of our perfect squares. 1, 4, 9, 16, 25. I think that'll be far enough to go. What perfect square goes into the 8? Let's see. 4. So we have the square root of 8. We're going to copy down the 2. The square root of 8 is the same as the square root of 4 times the square root of 2. Copy down the minus 5. Now what perfect square goes into 50? Well, that would be the 25. So we're going to change the 50 to the square root of 25 times the square root of 2. Plus 2. What perfect square goes into 75? That would also be 25. Square root of 25 times the square root of 3. So now we have 2 times the square root of 4 becomes 2, square roots of 2, minus 5, the square root of 25 becomes 5, square roots of 2, plus 2 times the square root of 25 becomes 5, square roots of 3. So now we have 2 times 2 is 4 square roots of 2, minus 5 times 5 is 25 square roots of 2, plus 10 square roots of 3. So we have this pair's like terms. This one is not a like term. So we can combine only the like terms. Positive 4 and negative 25 would be negative 21 square roots of 2 plus 10 square roots of 3. These are not like radicals, so we can't combine that any further. Okay, I put my chart back over here. I think I will be able to use that chart. We'll start off with 5, and we'll break that down to 5 square roots of 75, and then the square root of x squared. I'm going to write them all separately. Minus 2x square roots of 12 plus 3x square roots of 48. So the 75, let's see, we'll break down. That's 25 times 3. 25 is the perfect square that will go into 75. So I have 5 times the square root of 25 times the square root of 3. And we know that the square root of x squared, it's a square root and it's x squared. Those match. The square root of x squared is x. So that turns into x minus 2x. Now what perfect square goes into 12? That would be a 4. So I'm going to change the square root of 12 to the square root of 4 times the square root of 3 plus 3x. Let's see, what perfect square goes into 48? I believe 16 times 3 is 48, isn't it? Yes. Okay, so I'm going to convert the 48 into the square root of 16 times the square root of 3. So now let's simplify this. We'll have 5 times the square root of 25 is 5. And then we have the square root of 3, and then we have times the x, minus 2x. The square root of 4 turns into 2, and then we've got the square root of 3, plus 3x. The square root of 16 turns into 4, and then we've got the square root of 3. So I'm going to put all my outside parts together. 5 times 5 times x. Let's see, that would be 25x square roots of 3 minus 2 times 2 is 4x square roots of 3 plus 3 times 4 is 12x square roots of 3. So 25 minus 4 is 21. So we have 21x square roots of 3 plus 12x square roots of 3. Notice that our like part is the x square root of 3. And we only add the coefficients together. 21 plus 12 would be 33x square roots of 3. Okay, continuing with example 4, I have 5, and then I have the cube root of 32. Let's see, what perfect cube? I have listed the cubes over here. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Let's see, which one will go into 32? That must be the 8. So we're going to say the cube root of 32 is the same as the cube root of 8 times the cube root of 4 minus 3. Now let's see, what perfect cube goes into 108? Couldn't be 64, must be 27. Let's see, 27 times 4 is 108. So we'll have the cube root of 27 times the cube root of 4. So now I have 5, and the cube root of 8 turns into 2, cube root of 4, minus 3 times the cube root of 27 turns into 3 times the cube root of 4. So now I have 10 cube roots of 4 minus 9 cube roots of 4, which would be 1 cube root of 4. Or we might just write the cube root of 4. You don't have to have the 1 out there. Alright, example 5. I put my little cube root chart back out here so that I could refer to it. I have 3. Now, the cube root of 16, what perfect cube is in 16? That would be 8. So we'll have the cube root of 8 times the cube root of 2, because 8 times 2 makes 16. And then we have the cube root of p squared plus 2. Now, what cube root goes into 54? Which one would be 27, wouldn't it? 27 goes into 54, so I have the cube root of 27 27 times 2 is 54, times the cube root of p squared. Now the cube root of p squared will not break down. You remember we divide the index into the exponent, and 3 won't go into 2 because 2 is smaller than 3. We could only break it down if it were the cube root of p cubed, we could break it down. Or if it were bigger than p cubed, we could break it down. But we can't break down the cube root of p squared because 2 is smaller than 3. So we'll have 3. Now the cube root of 8 turns into 2. So we'll be left with the cube root of 2 and the cube root of p squared plus 2 times the cube root of 27 is 3, and we'll be left with the cube root of 2 and the cube root of p squared. So let's get all the outside parts together and all the inside parts. These go together, these go together, these go together, these go together. So we have 6 cube roots of 2p squared plus another 6 cube roots of 2p squared, which would give us 12 cube roots of 2p squared. Final answer there. Example 6, I put my little square root chart back here so that we'll have that to use. I have to use my rules of order of operations here. Please excuse my dear Aunt Sally. I have to do this multiplication first. 14 times 7 is 98, so I'm going to multiply that first, and I'll have the square root of 98 plus the square root of 8. So I want to know what perfect square goes into 98. That looks like that would be 49. So I'm going to change that to the square root of 49 times the square root of 2 plus what perfect square goes into 8. That would be 4. So I can change that to the square root of 4 times the square root of 2. And then I will have 7 square roots of 2 plus 2 square roots of 2, which would be 9 square roots of 2. Our last problem is a perimeter problem. I want to find the perimeter, so I want to add all 4 sides together. 3 square roots of 3 plus 3 square roots of 7 plus 2 square roots of 75 plus 2 square roots of 28. So I have 3 square roots of 3, that won't simplify. 3 square roots of 7, square root of 75, let's see, would be the square root of 25 times the square root of 3. And the square root of 28 would be the square root of 4 times the square root of 7. So I have 3 square roots of 3 plus 3 square roots of 7 plus 2 times, let's say this square root of 25 will turn into 5 square roots of 3 plus 2, and the square root of 4 will turn into 2 square roots of 7. So now I have 3 square roots of 3 plus 3 square roots of 7 plus 10 square roots of 3 plus 4 square roots of 7. Adding the like parts, I'll add the square roots of 3 together, would give me 13 square roots of 3, and then I'll add the square roots of 7 together, which would give me 7 square roots of 7. This is Jo Karen Hudson. Thank you, and have a wonderful day.